Waze is primarily a car navigation app, has some capabilities to report incidents whilst you're out on the roads, and also some smarts to detect when your car's kind of slowing down in traffic. Has a lot of users in Australia, and they also have this Waze for Cities program. This is a two-way data sharing sign-up that's free to join, targeted at government agencies. I know there's a number of transport agencies that use this in Australia, and also some local government authorities that are using it now. It's worth looking into. Esri has a partnership with Waze. There's actually a reference layer that you can add from ArcGIS Living Atlas if you just want to kind of eyeball what's going on in your area. But today we're using the feed to have a bit of a play around in ArcGIS Velocity and see what else can we do with that feed of information. So the very first step is tapping into that feed. So I'm actually tapping into the raw feed from Waze with a real-time analytic. And this is a very simple one. All we're doing, connecting to an HTTPS endpoint, polling it every minute, and it returns a whole bunch of JSON, including some XY fields, and we're just persisting that to a spatial temporal data store. There's no smarts required here. It just flows across perfectly. I might want to filter some things out or do some additional enriching of that data, but for now, that's all I need. This happens every minute, and it continuously tops up that data set. I could make it more frequent, but for me, that's all I need. What I wanted to explore was a big data analytic. So whilst the data isn't that big, that real-time analytic has been running for the last 10 days, and it will continuously top up. I'm not archiving anything. A big data analytic allows me to do more compute-intensive workflows and sort of schedule those to happen whatever makes sense for my workflow. So what I could do is, whilst the data is continuously being topped up by the real-time analytic, maybe this batch analytic just runs every hour or every night to sort of calculate and update some information products or some data sets that are then used in downstream dashboards and applications and other business systems. Basically a very kind of simple sort of pipelining tool. So to explain what's going on this big data analytic, first off, before we talk about that, this is the Waze data. Before we even look at the model, it's temporal in nature, so we can actually just grab that layer and start visualizing it. We can also see some of the attributes. So there's some really interesting attributes on these data sets. There's kind of this high level type, which kind of tells us if it's jams or hazards and things like that. But there's a subtype that kind of gets into more detail. And I can eyeball, what's happening in the last sort of 10 days. And you can already see that there's different kind of volumes of data, and that'll sort of maybe depend on rainy days or weekends. I could also, each one of these slices is a day. I could start going into the peak and off peak. I could also, because the layer is a spatial temporal layer, I can actually enable aggregation styles. So this is kind of just baked into spatial temporal layers. I can start to get an understanding of how this changes over time. Using a kind of a hex bin. You can already start to see where some of the freeways are just using this style. The model. So let's skip this. Let's turn on the roads. There we go. This is a road network, and we'll look at why we're going to use that in a sec. At the top here, I'm doing actually a fairly simple hotspot process. So hotspot tool has a whole range of parameters in it to set time windows and spatial windows on defining exactly what a hotspot is, and there's a lot of debate a lot on if I've chosen the right settings there, and that's fine. There's a lot of other studies using kind of crash data that I kind of gleaned off, but it does allow me with the output result to kind of get a feel for, okay, well, where are these persistent hotspots that keep happening? So I know that I've been stuck at this set of traffic lights quite a few times, and the data kind of backs that up. There's always a kind of a backlog of traffic there. But what it doesn't do is it doesn't tell me if it's either side of the road. It's just looking at the bunch of points in that area and kind of aggregating it without any kind of knowledge of if it's which driving direction it is. But it does calculate that every time. So this isn't a desktop study. Every time this runs, it'll calculate that and top it up with the next day of data. For the other apps to use. I don't have to keep sort of opening up ArcGIS Desktop to do this. All right, so let's move on from the hotspot. The snap to network is pretty cool. So this is more than just snapping to the nearest feature. these road segments, they have a whole bunch of attributes around the driving direction, and if it's two ways, or this particular segment is just one way, and which direction it is. And that's important because in this Snap to Network tool, it allows me to essentially take the Waze incidence. So if we take a look, the Waze incidence, again, we'll use this junction. What we can see is, they don't always, let's find a busier junction. So we can see that the incidents, or the Waze incidents, don't always sort of snap onto the road network. And we also, it's worth pointing out that these incidents have this magvar is basically the orientation of where that device was heading from the device's sensors as part of that attribute. And in the Snap to Network, we can use all of that. We can use it uses the fields in the road network to know what's left and right and what direction it is, but it also uses that bearing distance. So it's not a case of just snapping based upon the nearest one. It actually has some smarts to work out which is the right road segment to snap it to. And we add that on here. You'll see that it's taken all those incidents and snapped them to the relevant road that it belongs to. Or if not, because there isn't the right values, it won't do that. Okay, so with that, I persisted it to this data set here, really just to sort of show it on a map, but I don't really need that actually in my model. I'm taking the output of that, doing a spatial join. So I'm taking the incidents from Waze that are now snapped to the roads, doing a spatial join back to the roads layer, and that then gives me a count. So, just doing a spatial join, it gives me a count of the unique features that are, in this case, just a count of the Waze incidents against that road segment, very simple one. And then I'm also calculating a rate. So there's different ways of doing this, but I've just taken, because each of these road segments are different lengths, I've taken the count of the Waze incidents and divided it by the length of the road segment to kind of give us a rate field. You can get more complex with how you calculate those rates if you kind of want to take into account the last 10 days or the last year of data and things like that. And that's it. So that's calculated this rate field, which gives us this final layer here. Let me turn some of these off. And this is now a little bit more smarter than just a simple hotspot map that doesn't know about the sides of the road. So this is now actually, okay, maybe in certain junctions it's just one side of the road that's going to be more problematic than the other. And it kind of gives, zooming out, you can start to sort of get a feel for what's it like across the network and is there particular problem areas. And, you can, again, extend this logic. There's a lot of crash studies that have been done at the desktop study level. You can sort of take that logic and sort of feed it in against, using the Waze data for that as well.